Alright, hey there my Math 2 students. This is a basic overview video for 5.6, which is more than right, so we're getting outside of right triangles. This is a developed task. Basically our essential question is to explain the law of sines and how it was derived. You can see here on the notes that there's the law of sines, but just memorizing that isn't really going to help you unless you understand how it's derived, and that's what I'm going to show you some of the stuff on the task. Here is some vocabulary words that are going to help you understand what happened in the task. Here is another way to visually organize the sides you use in SOHCAHTOA. And here are the questions on the sticky notes, but I'm not going to show those to you on the video. You guys have to look on OneNote to get those questions. So you can see these notes on OneNote. This is just the beginning page to start our video here. Basically on this task, they give you a couple of triangles, and you can see all of my chicken scratch here trying to show you how to find all the sides and angles in the triangle based on just using sine, cosine, and tangent. So one of the biggest things you have to do is be able to draw an altitude to make two right triangles. That's what I did right here, and I have to use the length of this altitude I'm going to use as z. Okay, so B is there, A is 10, we know 40 and 65. You can look through most of my other work here trying to find out all the other measures in that triangle. Okay, then we have a different triangle. Okay, they drew an altitude, I drew an altitude from C to right here, and we figured out the rest of the stuff like this. Now I left it all open like this because this would take us forever to go through in class, and I want to give you time to look through all these equations and see where they match up on the diagram. The more important part of the task is right back here, and this is how we really develop the law of sines and why it's always true. We have an obtuse triangle here, and we drop this altitude from C, we make two right triangles where B is the hypotenuse of this one, A is the hypotenuse of this one. Angle A is over here and angle B is over here. We can set up the sine ratio to find A. We can set up our first side A, we can set up the sine ratio from this right triangle. The sine of B is opposite over hypotenuse, so that's equal to y over A. Let's do the same thing over here. For letter B, the sine of A right here is opposite over hypotenuse. They both involve that y, that quantity right there. And so what I did is I rearranged this equation. A is equal to y sine B. Rearrange this equation. B is equal to y sine A. Change those both around, isolate y, and boom, you get the first part of the law of sines. This altitude right here equals A over sine B. It also equals B over sine A. And if you rewrite that, you can begin to see how we get back to the law of sines. The law of sines is basically saying the sine of an angle over the side opposite of it is the same ratio for all three angles. That's what the law of sines is saying. One more time. The law of sines is saying the sine of an angle over the side opposite of it is the same ratio for all three angles and all three associated sides. Okay? So that's explaining the task. Let me go through the RSG problems really quick. On the ready problems, you're going to use whatever trig functions you can figure out to find the area. Use 1/2 of the base times the height. You have to use a special trig ratio or a trig function to find that height. Same thing here. We have to find this height, probably using, I don't know, sine. What down here on number 4? We have to find out what this height is using tangent or sine of this triangle right down here. So that's what's going on the ready problems. On the set problem, oops, wrong page, sorry. On the set problem, number 6 is your homework. This is extremely difficult. I'm going to step you guys through in a different video how to solve number 7, and hopefully using some of that logic will help you on number 6. And then lastly, the go is to Wow, a bunch of go problems. Fill in missing measures on this triangle using special right triangle ratios. That's the stuff we worked on in 5.5. And the same thing there and there. So remember and use all those special right triangle ratios. Okay? That's your general overview of 5.6.